In order to get a high-resolution climate record reaching as far back in time as possible from ice, we must analyze the deepest and oldest parts of our planet's ice sheets. One challenge relating to analysis of deep ice is the issue of layer thinning. There are vast ice sheets covering the landmasses of Antarctica and Greenland. These ice sheets are not static. Under the effect of gravity, glaciers constantly flow. In the case of Antarctica, this flow happens from the center of the glacial mass towards the edge of the continent and the ocean. One effect of the ice sheets flowing is the thinning of ice. A layer of precipitation deposited on the surface moves over time as more layers are deposited on top, and gravity pulls the ice downwards and outwards. This results in ice layers deep in the structure being much thinner than they were when initially deposited as precipitation at the surface. Towards the bottom of the Antarctic ice sheet, tens of thousands of years of information can be packed into only 1 vertical meter of ice. Therefore, in order to fully scrutinize the ice, high-resolution analyses of ice samples must be performed. Resolution is defined as the smallest increment over which a technique can collect a data point. High-resolution instruments used on ice samples collect data over very small intervals of micrometers or smaller. One established approach to measuring the properties of an ice sample is meltwater analysis. Typically, this approach can yield up to 1 data point per vertical centimeter of ice melted. Deep ice demands a much higher resolution and, ideally, analysis that does not melt scarce, precious samples. Research is being done to apply high-resolution, non-destructive techniques to ice. These new developments are probing ice at the microscale, giving information on the optical, chemical, and physical properties of ice at resolutions of micrometers or higher. This progress is well timed for application to deep ice, such as the core currently being extracted at Little Dome Sea in the framework of the Beyond Epoca Oldest Ice project. The Beyond Epoca ice is projected to have a layer resolution of 17,000 years per meter at a depth of 2,500 meters, meaning that high-resolution analyses will be vital to obtain detailed information from this deep ice. I'm part of the Deep Ice project because I want to contribute to novel research pushing the boundaries of our understanding of our planet.